There was some creating channels on Discord. Did that get resolved or not yet?
I think you need to give us your administrative access.
I see, but nobody has it other than me.
Yeah.
Even you don't have it.
Last time you gave me your account.
Okay.
Logged in on my computer. I think it's
Oh,
still-
I see. Okay, so maybe right after this, but did people figure that out somehow? So at least there are teams discussions that have happened, right? So today we're doing FRDPARRC discussions. I'm assuming, do we want to use Notion or whichever way people have been putting documents together? Is there a single place or do people want to connect their computers or they want to use whiteboards? Okay, yeah, I think on a Discord, let me just create a document. If you have a link, then we can go through that faster. So I'll create a specific channel just for the discussion for this. And then I'll just mention this for everybody itself. Okay, I think we'll just do it here. So please post documents here. That way we don't have to keep changing back and forth computers. Okay, so just as a recap, what we are doing today is discussing projects. The idea would be is by now everybody has a clear sense of what you might want to tackle. And then we'll go through logistics of thinking about how to get where we can at least test an approach. And I think we discussed the date for trying to do final presentations would be around, what was the date? It was the last week of the quarter itself before the finals week. Yeah, we should ping that. Can you pull that out just for a second so that we can post that there? And then folks online, I think maybe what we'll do is we can just start from teams that are already starting to post. So what I've done here is you can see I've created a channel right there. And in here, folks that are online, please post a document here and then we'll just do presentations through that. If you don't have that, you can also use a whiteboard. Also just discuss. It would be valuable that everybody gets a chance to go through it. And since we don't want to waste any time, let's just get started. So I'm already seeing Jackson, Merit, Ramaya, and Selena. So do you guys want to come up and talk through this document for everybody? I'm gonna try to see if as a table. Yeah, it's useful to everybody to come in and just, this will really be a much more of a discussion. So this is mostly informal, while the talks that we will do much more formally. If any of you want to control the computer, we'll just kind of listen in. And I think folks should interrupt as much as is needed because it's valuable to try to sort of both defend some of the ideas, see whether this leads to an idea discussion to a point where there is real clarity of what you might want to tackle. Yeah.
So our idea.
Is there a team name you guys have?
Yeah.
Yeah, everybody should come up with a team name for folks to remember. Yeah.
Yeah, so our idea is to test for the potency of antimicrobials. We haven't quite decided what kind. It might be herbal or pharmaceutical. So we can start with the functional requirement.
Yeah, so in terms of potency, we need rate of killing. And then for antimicrobials, like Selena said, the pharmaceuticals are serious, like antibiotics and so on. And as well as for microbes, there's different kinds, pathogenic bacteria, which we talked about in class a little bit, and molds as well was an interesting category that we were discussing. There's a lot of like molds that produce like mycotoxins that are in the environment, are in food. That's again, there's like antifungals that are used for these things. And then parasites is another category. So those are so again, this is a little broader now, but
Sorry, can you maybe go closer to the computer when you talk?
Oh, sure. yeah, sure. So again, we're talking about potency, and then there's a few types of antimicrobials that we're thinking of like employing, as well as a few types of microbes. And I guess for example, like one example would be the like how like various herbals could be used for bacteria.
Yeah, and then for like the scale of understanding the problem, we looked at like some numbers about like what percentage of antibiotics in like different countries are actually like passing a potency test. And we saw that like around half from like India and Ethiopia passed the potency test. And then like this study specifically like showed like the same. And so we thought that was like concerning because like that means that a lot of antibiotics aren't actually like working in those countries. And so that I guess could like justify at least like a little bit some of like the use case of this kind of test.
So just to clarify, what is the procedure when they come up with that number of 53.7%? They actually do, because
Yeah.
there is a very large number of antibiotics and there is a large number of microbes. And so that number is an average.
Yeah, they like I think Selena also was talking about this, but they basically take like the radius of like
Yeah.
the amount, and then they did that for like 4 different types of antibiotics, including like amoxicillin,
Yeah.
I think. But I'm not
But for a
Yeah.
standard pathogen or
Oh.
circulating pathogens in the environment. Because they are tested against clinical samples.
Yeah,
Right, that's
yeah.
very important. Just because you could kill a lab bug doesn't mean you have to kill the bug that was collected from patients.
Yeah, I'm not exactly sure where the data comes from. Mira put it in, so we'll look
Yeah.
more into
Yeah,
that.
the reason I'm just mentioning this, it's in a very interesting way, it is exactly where your earlier requirement itself is. Like, do we even have a capacity to know what's working and what's not working?
Mhm.
Right? And it's very close to what you guys want to build. And in some sense, these numbers might actually be an underrepresentation of what's actually happening. Because we don't have the capacity sometimes to be able to do the same.
Mhm.
Yeah.
And other functional requirements we came up with, including a low cost, it being like importable and also durable, so it can be used at multiple times.
Yeah, so for our design parameters,
So just before we go, anybody else have any other suggestions on functional requirements? Anybody sees anything that they want to comment, something that you don't see? Can you go further down just a little bit? Yeah, I mean, I think one way that I would just suggest would be is to make it as particular as possible in a sense. So choose, choose a specific category, and then in the cost, choose a number. Because low cost can mean many different things. So it would be valuable, the more you feel like you're constraining yourself in functional requirement, more it is useful in terms of then choosing many of your design parameters. So rather than feeling like it's funneling out, it will start narrowing down.
yeah. So hopefully we'll kind of have more design parameters as we kind of take on that feedback, but as we discussed, we're sort of choosing between herbal antimicrobials and pharmaceutical antimicrobials. And another design parameter that it would be important to discuss is just users, who are we sort of targeting this project at? There's a possibility that it could be targeted directly towards citizens so that we can empower people themselves and LMICs to test their medications and substances to make sure that they're safe and potent. Another possibility is targeting these devices toward community healthcare workers that they can do that work, as well as herbalists or lab scientists. It's still very much an unanswered question for us, and any feedback that folks have, any recommendations, we would very much appreciate.
I think one insight that we were thinking about was like how it would be hard to like access like parasites and like bacteria for like if those citizen scientists or people, so that like if we were to do like if we were to focus on like our like narrowing it down, if we're to narrow it down to like pathogenic bacteria, I feel like that would kind of limit our users to like lab scientists probably. But if we're maybe doing something more accessible, it would change. So like I think when we narrow that down, that will also narrow the users down. So that's that we were
Yeah, I
debating
think
with
it's
this.
one interesting way where this thing can meet an everyday person running the test is when you compare diagnostics. So currently, at-home diagnostics is becoming much relevant. And I'll give one example. I think the urinary tract infection is a classic one. And then there is also a motivation that the person has, but often enough, the person doing the diagnosis, if that's happening outside a medical centralized facility, there is also a requirement, or at least the need, that you know what drug would actually be potent. And so there is, so that's really when the user has access to a path. It's not a screening tool. It is, at that time, it's a diagnostic tool. But right now, for a lot of bacterial threads, what's becoming almost a requirement for all diagnostic tests is they also do a dosage curve. And they also tell which exact drug kills. It's not sufficient enough currently to just say that you have E. coli as a UTI. You want to be able to say that for that particular strain, which drug would be used. So there's a very interesting intersection. I can see that this could remain as a centralized, much more scaling, screening, testing, or it could really be if it's in a citizen context. I think this is where you will see a bifurcation. Then this capability combines with a traditional diagnostic test, in which case, by definition, the user has the wealth because they have access to the exact same pathogen. So yeah. Other design parameters. Yeah, this should really be a discussion. So just feel free to give feedback. Yeah.
I guess like going back to the functional requirements, one question. For these stats about like the half of the antibiotic stock, you know, like to what extent was that caused by like the manufacturers themselves, or like storage conditions, or like where were these tests like in these stores and stuff? Still more color to why maybe that number's still up.
Yeah, I'm not really sure, but we'll probably have to go through like the article again and stuff. But like the idea about like expired antibiotics was also actually something that we were looking into, because I read like an article about like how a lot of expired antibiotics aren't actually like expired to the point where they wouldn't be effective, like they would still be effective. So that might be also like something that we were considering.
Yeah, we also read that 1 in 10 like drugs, pharmaceutical drugs are fake when it gets shipped to LMIC countries. Yeah.
Are you interested in calculating like the actual percent purity, or are you more interested in determining if it's pure or if I know it's pure or not?
So we were actually debating between potency and getting the entire spectrum of stuff inside the medicine. And we thought that doing like spectroscopy or chemical analysis to determine what everything that's in it would be too complicated for a frugal approach. Maybe it's possible. We haven't thought about how to make it happen. So we thought a more feasible approach would be to use microscopy. Then we can just look at what gets killed under a microscope.
Yeah, I think let's go through the other bits and then we'll kind of come back. Any other things you guys want to mention?
Yeah, so we thought a bit about the logistics of how it would work. We thought about where we could get the microbes from. There are mold kits apparently that people sell for you to test whether your antifungals are working.
Mold kits are for like collecting mold.
Oh,
Yeah, it's like you can have like, you can either have a swab or like an air sample or something, and you can put in like an agar, and then it'll like reproduce. So like that's the way to like collect it. Yeah.
I think this is mostly then when you ship it to figure out somebody else identifies it.
Yeah, I mean, I think in terms of, there's actually like mold growing, like I think for people who have like mold issues and like water flooding and stuff, they can go to like Home Depot and get like a $10 mold collection thing to see if there is mold in like the walls or whatever. But in terms of killing the molds, or like, that is like a much more expensive and intensive process to like figure out how to do that. Because the issue is like even dead molds still release toxicity. Yeah, so but for the bacteria, that's
yeah, for bacteria, we're not sure. I see that there's some freeze dried and there's also like clinical isolates that people ship cold.
Yeah, I mean, I think the big comment that I have, oh, go ahead, Baba. He has a huge source of bacteria. by
Yeah.
the way, that we use in the lab.
No, I'm wondering, I really like the potency, just on the, I really like the potency idea. I'm wondering though, like, if people's concerned about the other things, and I wonder if you can do the bacteria or whatever you use with that potency, you can look at like long-term effects of this particular drug, to see, like not only look at the rate of killing, but see if there are any extraneous effects of using it. To give people more reasons, if that makes sense.
Like the effect on the microbe or effect on the
Yeah.
human body.
Either way, I probably first pass micro. See if you're testing it, but I wonder, like, I think potency is enough, but to get, it seems like there's a kind of you want to keep in mind that thing that you use is really good.
Yeah.
And so like covering all your bases, like your and
I think especially if the trend becomes herbals or others, the assumption here is that the medicine is already safe for human use. So that's a given assumption. This is not a discovery platform. This is just whether what I'm being told is actually correct. Especially you pick something from the market, and if you don't believe whether it has what it does have. Yeah, I think we'll switch. We'll kind of just do this much more as 10-minute threads, so everybody gets a chance to go through. But one comment that I'll make is try narrowing it down even further. Like rather than 3 specific pathogens, choose one. Choose a specific country setting, for example, and choose something where one class of compounds are really being tested, because the fake drug problem is a little different from the resistance problem, is a little different from the herbal problem in a way. And although you can then later on, if the platform operates and works in a manner that it is applicable to others, that's great. But while developing it, it's because it will change dramatically at what scale you need to do this, and how often you need to do this. What is this, a high throughput instrument? Is this a one-shot thing that people do at home? And then look at what the current diagnostic instruments that currently do the ACT and a couple other tests on for potency. So you'll see this as antibiotic resistance rises. It's almost becoming a requirement for all diagnostic tests to not stop at what bug it is, but to actually tell a clinician what should be given to the patient. It's not on clinical judgment anymore, because it doesn't matter. The strain might be resistant to XYZ. So the trend is moving towards that anyway. And I think then it becomes very interesting, because then it's happening at the patient right before taking a drug, before knowing the diagnosis. Okay, let's switch. Who wants to go next? I don't know if there are, Samir, do you want to go next? Okay, so I am clicking on the next And then on the online side, try in the chat writing your name down so that we can have folks coming in, and I can go back and forth between the online talks and folks here in person. Okay, Samir, it's all yours.
Yeah, so I'm doing this with Rune. Rune's on Zoom. He couldn't make it in today. But so our idea is basically to so our idea was inspired by earlier in class when Money was mentioning like the supply chain issues with Raspberry Pis and like the cost of getting them in all these systems. Our idea was like how could we maybe like have a Frugal replacement for Raspberry Pis and other sorts of computers using these systems. So our idea is basically, can we use old smartphones to replace these in any project? And so there's a couple of like benefits, especially of using smartphones, namely like they come in with other built-in features like, you know, there's GPS, there's cameras, there's other things that you would otherwise have to like purchase separate and adding to the cost of your device, and doing custom integrations. Yeah, the really nice thing is that there's always new phones coming out. I think I have a stat. Yeah, so like for instance, there's almost infinite supply of like cell phones. Every year 1.5 billion cell phones are made, and then within like 5 years the value of the cell phone drops drastically. I have like some stats also, ultimately getting to a cost that's like basically just as expensive as a Raspberry Pi, or cheaper than a lot of other controls. Like in the Octopi paper, I think you guys also used like a Jetson Nano, and that was like $100. And so in addition, like if you notice right now, the supply chain issues with Raspberry Pis, you can't even buy one currently. So it definitely limits people's innovation. I don't know if Rune, you wanted to chat a little bit.
Yeah, I mean, I think the biggest thing is like right now there's a lot of scalpers on the market who will purchase the Raspberry Pi. Like if you can get a Raspberry Pi for $35 from the official sources, that's great. And I feel like there's no way we can compete with that cost using a cell phone right now, in terms of the compute that a Raspberry Pi provides. But for the most part, everything we saw online was like you have to spend $70 or more to get a Raspberry Pi, and that doesn't give you a screen or a camera or any of that. So we think like maybe in the future, if the supply chain stuff works itself out and everyone can get a Raspberry Pi, maybe this project isn't as useful, but at least right now it seems like this could be useful. And maybe, you know, as smartphones get cheaper, as Sumer said, like the price will drop on smartphones as well, and it might end up being cheaper than a Raspberry Pi.
Yeah.
Warren, the comment that I would make is actually, I mean, in some sense, what you're really addressing is giving cell phones a new life. The bigger problem I see is not the fact that Raspberry Pis are not accessible at this moment, but what happens to those 1.5 billion cell phones every year. So as we sort of think about, I mean, from a technology perspective, unless we can stretch the life of a cell phone to do many more things for much longer, that by itself is untenable. For the amount of resources that go in, I mean, there's so much engineering that has gone in. Raspberry Pi is a good project, but for even if you're making an OEM product, for example, we, like for Octopi, we go in and put more industrialized products as the controllers in it, because eventually you really want to deploy a product.
Yeah.
And so cell phones are they just meet that kind of a market, and simultaneously possibly increasing the capacity.
Yeah.
So I would sort of think about it's not a competition with Raspberry Pi, it's a complementary access to think about.
Yeah.
And I wouldn't think about this much more as a short time, but really flip that around in terms of you have this incredible resource. What would be valuable to know is how many cell phones are being dumped every year. And I think what does the recycling path of that looks like? And maybe, okay, 30% of them are taken back, and I don't even know what they do, because extraction of precious metals is really impossible. That industry is fraught with all kinds of problems. So anyway, I think you guys have hit upon a really fun problem. There's a lot of value in thinking about it.
Yeah, and I think one thing to note, like for these systems, as like machine learning models become better and better, like you'll want to use GPUs, and so phones
you
have
go.
them built in,
Yeah.
which is nice, and they're generally pretty expensive otherwise. Okay, so I think kind of in terms of the scope of the project and what we kind of want to start, we were focusing on kind of replicating the results in the Occupy paper. I think that's like a good system to start, and using a smartphone just to perform all the computation. And so we ideally want to also hit the benchmarks that that paper showed. So like in terms of time, and also like power draw. Though we know that one will probably be harder to accomplish. Yeah, and so then cost as well, and obviously we shouldn't just integrate with a Raspberry Pi, obviously. And so yeah, in addition, I guess one thing we didn't specify here, but we were discussing was like what operating system of a phone do we want to try? Do we want to try using like a Google phone or like some Samsung? What are the differences? What versions of Android? So probably we'll just like pick one that seems the most compatible, and then if that works, then we can try to like make that more general as well.
Any comments on functional requirements before we start?
Sorry.
What do you mean by the second one?
Oh, this is more of just like it's like a obvious, like the final system can't also contain a Raspberry Pi.
Oh,
So the idea is like to not use a Raspberry Pi, right?
Yeah.
Actually, I think, sorry, maybe that part isn't clear. Point 5 is supposed to mean like if someone wants to use a smartphone rather than a Raspberry Pi, it should be as simple to do so as using a Raspberry Pi. Like ideally, if we want people to be using smartphones rather than Raspberry Pis and giving these like devices new life, then it shouldn't be a giant hurdle where like someone has to know how to program an operating system and do a bunch of like systems level programming in order to get the thing working. It should be as simple as programming on a Raspberry Pi.
And I think this is a huge issue. Currently, cell phones don't open up much of their access points.
Do you guys have numbers on like how powerful like a Raspberry Pi is versus and I imagine an iPhone, they have like a lot of RAM, like I imagine they're actually.
Yeah, they're like more powerful.
Yeah.
Yeah.
I think I did some research into this, and if you look at like the S10e is one of the phones that we looked at, and it's like $82. And I think it's slightly more powerful than a Raspberry Pi, has a much better camera. Oh, this is just like pricing, but it's like slightly more powerful than a Raspberry Pi, but it comes with like a camera, GPS, battery, a screen, and it's like $12 more than a Raspberry Pi.
Yeah, but we can include specific like computation numbers.
Yes, one comment on the functional requirement. I really like the fact that you chose, we're going to do exactly what was done in that paper, because then you have really prescribed a target. Because it's very valuable to choose a hard target. It's like, okay, we're going to implement everything that we implemented in the Occupy paper. Then every little detail of the power, the time compute, you are holding yourself to. And it's okay, some things will be met, some don't get met, that doesn't matter. But I think being very specific. So I like that. I think the thread there is that's a malaria platform, and that's a very large problem by itself.
Right.
So by putting your hands on something very specific, you shouldn't feel that you are curtailing. You're just helping yourself implement better.
Right.
And of course, this would be very much more generally useful.
Right, exactly. I think part of it is if we do have some working version, then like that can actually be used.
Yeah.
Something that's really cool is that like for fieldwork, I mean, Raspberry Pis are kind of sensitive to the pack, and you put like an insane amount of bubble wrap, it takes a package like this big.
I mean, waterproofing, for example, is something
Right.
Is most exciting. It turns out now most cell phones are waterproof.
Right.
Which is a huge issue for a lot of
Like,
products.
it would be so much easier to practice.
Yeah. They're also like, they're decently good at not breaking nowadays. So
Okay, there is a risk that we can talk about, but I don't. Yeah, do you want to cover anything else and then we switch?
I mean, this is just kind of going into some details
Yeah.
of control systems.
Yeah,
So that's more like technical
yeah.
details, but
Let's just mention any of the risks that you guys have identified just briefly.
sure. Varun, do you want to go? over
Yeah,
these?
I can talk about these. There were two approaches we looked at. One is using like a very cheap Arduino microcontroller to communicate with the device, and the other is just using the USB port on a smartphone to directly interface with the motor. So one refers to using the Arduino, and two refers to interfacing directly with the motor. And we haven't fully fleshed out all the risks yet, and it's a little bit difficult for us to anticipate all of them too without prototyping. But some of the things we've anticipated are looking at that first point, point A. It's possible that the components for a smartphone aren't as easily controllable or interoperable with other components. So in the Octopi paper, one of the things that's used is like a magnification lens on top of the Raspberry Pi camera. And it's possible that that lens doesn't easily adapt to our smartphone camera or something of that nature, where there's issues like that. And then I think also if we decided to add a function, this isn't written down, but if we added a functional requirement that like the smartphone should be more resilient to damage than the Raspberry Pi, like if we're opening up a smartphone and we're like pulling out components and moving them around, I'm sure we lose the water resistance and we lose the resilience there. So that's something that we should keep in mind as well. Looking at point B, there's also might be issues with extending connections from the smartphone to like the Octopi device. So like the ribbon cable on the smartphone camera might not be long enough to reach where we need it to. And that would require us to redesign the Octopi or find a way to like incorporate a longer cable. I think, let me take a look. Oh yeah. And then I think finally, the last thing would be if we decided to build a circuit between the phone USB and the motor, then that might need to be printed onto its own PCB, or we might have to like expect the user to build the circuit on their own. And I don't know how reasonable that is for a user to maybe be soldering a circuit by themselves. So that circuit, if we decide to like print it onto a PCB to make it really easy, that might come with additional costs that we're not anticipating, or it's possible that it's less resilient to like external environments because it might be a little fragile.
Yeah, so what we'll do next week is we will actually go through, because we're gonna cover Frugal optics next week, and we'll cover through the entire chain for Octopi just in general. So you'll see that many of these things are not that big of concern, because there is also already a control board, which is very specific to the hardware.
Okay.
I think the way that I'm really thinking about the cell phone, the biggest thing you should be thinking about providing compute power.
Mhm.
That's the most important thing that cell phones bring to the table, especially because we want to put machine learning models on top.
Right.
So even if that's knocked off, that's fantastic.
Gotcha.
The big risk here is which platform you choose and how open they are
Mhm.
for, and I think, this is why you should identify an OS as quickly as possible.
I mean, I think it's
Choose
all.
one specific phone type, because the big reason, I mean, there can be many big reasons, but most of the time, the entire stack, the development stack is actually not accessible on cell phones.
Yeah.
Which is sort of why we moved away from it.
Gotcha.
But,
Yeah.
I mean.
We'll
things
definitely
change,
use some
and
Android
then, of
version, but yeah.
course, there might be certain class of projects that are brewing. I don't know whether there is actually an open source cell phone. There used to be a couple of projects in that space.
Yeah.
Which would be worth looking at.
Okay, yeah.
Yeah.
That's a good point.
I think we talk about this a little bit in the counters. There are some Android smartphones where the manufacturer lets you unlock the bootloader and flash whatever software you want onto it. And there are open source implementations of some like Android operating systems that you can, as long as you can unlock the bootloader on the device, you can load that on. So that's kind of what we were looking at. We would isolate a device based on how easily we can get access to the bootloader.
No, that's fantastic. Okay, let's switch. Do you guys have a team name?
Oh.
It's okay. All right. Come up with team names. Anybody online wants to go next? I'm seeing Kimberly here, Steph, DU. Okay, why don't we do DU and then we'll come back, so that way we do mix and match with folks that are online. So Diu, I'm gonna click on this Miro board and I'll let you take control then. And you can tell me, yeah, maybe while this is forming, you have to tell me, oh, can you zoom in when I do that? No, I have to zoom in on my end, right?
So you want to have the control, right? Of the.
No, you can have the control. I don't need the control. There you go. I stopped sharing.
Okay. Then I share to this. Okay, this is working, right?
Yeah, go ahead.
Okay, hello everyone. So, well, we are having a discussion on how to frame it better because we are being a bit wide on the possibilities. But to pin it down, considering just the wide problem of import of goods and the carbon emission of petroleum-based products and pollution of microplastics through single-use disposable products, even considering the trees to produce the paper. An example we chose to work on is the disposable paper coffee cups, because they have plastic or PLA bioplastic that makes it impossible to recycle or very difficult. And then the proposition is how to avoid this through the creation of reusable coffee cups and the possibility to produce it locally everywhere. So here we're talking about local production of biomaterial goods, and we chose the coffee waste as our main resource because we think there are a lot of possibilities we can do with it. But just to pin it down for an example of a fairly complicated thing is to make a reusable coffee cup. And then, well, we have some
Hear me?
Yeah.
Yeah, I was just gonna make one comment. What's very interesting about the problem that you're picking up is twofold. Often enough, a solution gets implemented. I mean, the whole reason paper cups got implemented in the first place was to reduce plastic use and bring more bio-friendly products to the market. But then to have that function work, it still is coated with plastic. And so that still suppresses. This is the same story. There are a couple of papers that are out there that show that many biodegradable products are actually not biodegradable, which completely defeats the purpose to even begin with. So many of those sets of plastics have not been rigorously tested. And a similar story I'm reminded of, there was this massive ban of plastic bags, if some of you remember, in many countries. I don't know what the California status is. And in the market, that got introduced what was called a fabric bag. And so Indonesia is one example, but it turns out that that fabric bag is made out of plastic and it's only a one-time use bag. It just looks like a fabric because it's the plastic in there is not one smooth, it's made of a microfiber, which is even worse because then it turns into microplastic faster. So many a times when you pick up a fabric bag and you think it's a fabric bag, it might actually not be. It's just and especially in the context of the single use. So I love this kind of a framing because effectively it's a larger question to also just think about.
Yeah, we'll give it a thought. So, well, we had some numbers of the amount of billion of single-use coffee cups and yeah, all the toxicity that it has. But anyway, it's just extremely so. Yeah, the functional requirements. So we are framing it this local production of sustainable goods made from food waste biomaterials with coffee grounds as an example. And then the coffee cup, as already said. And then we want to work on very different levels of production. The idea is how to build decentralized local production that are accessible to all communities. So yeah, we have in consideration being cheap and frugal, environmentally friendly, and then open it to other organic waste, not only coffee. And then if we can do the coffee cup, then we could do many more other things. About the cost, we were thinking on the cost of the units, just to put some goals. Then if we can develop with handmade biomaterials, only with kitchenware, so then the cup should cost like $1. And then we can kind of improve if you use a mold or no. And then the next level of complexity is if you have kind of a mini factory that is very low-tech machines. And then in this category, you already have very frugal machines that is just €100 investment. And then already go up with a heat press that is also kind of low-tech, but better quality. So yeah, a bit more like $500 investment. So yeah, this could be a way to replicate these biofactories everywhere with ways that is not only the coffee grounds, because coffee grounds we have in the cities, but then you also have in the production countries, you have the waste of the organic matter of the agricultural waste. So then you have a lot of other fibers that could be used. So then what we are thinking is how to connect the point of view from the, let's say, Indonesia in our case, from the production sites, with more fab labs in Europe, or also artisanal local products.
So do you just, and team, one thing that I didn't hear, which is essential, the technical functional requirement is temperature. I mean, so first of all, why is it that paper cups have a plastic lining? One is at a given temperature, you don't want it to leak for a certain amount of time. So that's really the functional requirement of the product. So in terms of the numbers associated with it, that would become very valuable. Of course, at given temperatures, certain materials start breaking, and they also release other sets of compounds. So the requirements for what material you can use, and again, you know, I think there's nothing fundamental about degradable materials can't handle high temperature, but you have to sort of write that down explicitly. Do you see what I mean?
Yeah, just the, I mean, we have two problems, the waterproof one and then the hot water problem. And then
yeah, just I think as a ballpark, a boiling water, a cup should be able to hold boiling water for at least 20 minutes, right? I mean, this is the same thing with the paper straws. They melt in your mouth, like my kids chew on them. And it's like, yeah, I'm not sure if this is working. But I mean, if you, so I think make a target, and then it becomes very valuable in what class of materials. And I think the way that I would approach this is approach this as a material science problem, not a product, like a specific design of a cup, because you're using the cup as an excuse. If through this process, you actually discover a material that is biocompatible, handles high temperature, and is still degradable, that as a material has massive applications. And I think, you know, that has an exploration is still not there yet. And I mean, top of my head, I cannot name a material like that until the threads that you mentioned that are all just classic polymers. So what that becomes is through the functional requirements, you might focus on what might be the Achilles heel of that problem, like the most important thing, while the rest will all come into place. Like I think turning it into many shapes and forms might be fairly standardized, but what's missing of why can't other people do this? And I think that might turn out to be a materials-oriented problem for a purely degradable cup.
But also, I think, yes, that's the case. But the thing, we chose this topic just to also make the point of even solve it without maybe, if we can develop a material that is very, you need some infrastructure that is very, a bit more complex, but then you don't have that in a very low-tech environment. So the choosing the cup, I think it helps to say, look, you can make maybe with another technique a very, very cheap one, and then we can go higher until yes, the end is just to learn how to do anything, but just through the example of the.
And so the other feedback that I would give is choose a scale, the kind of solution that you're trying to create. Although it would be nice if that same solution works at every scale, but from a context, it would be useful if it either works for individuals or small scale operations, or it works for larger scale operations. All it works for, billions of cups that are made every year. So choose a scale, and it's okay if it's not the same solution for every scale. Because again, I'm just trying to narrow down the functional requirements such that it feels like, one solution might not fit every possible requirement.
I mean, that's basically what we were thinking. I think in the design requirement, while we were looking into like the users and the manufacturing process, we were basically trying to figure out, okay, like who do we want to approach, basically, because we know like one method probably doesn't suit all. And so that's why we basically in our mirror board, we've managed to like set out like, okay, like who are we approaching? Because like, for example, me and Tafia, we're from Indonesia, and a lot of like when we think about coffee, there's a lot of relation to it with like coffee farmers and coffee villagers. And so is there a way that maybe in terms of like the method of production, we could sort of like combine indigenous or artisanal methods of productions, and maybe like providing sort of like low cost DIY tools recipe to empower the community in producing like this coffee biomaterial? I mean, this is basically one of them. And maybe for individuals, can it be done in home kitchen? Shannon, you want to go on with the Fab Lab and the coffee shops as well?
Yeah, and because we were looking at the team and how spread we were, and here me and Paddy are in the Fab Lab back in Geneva, and we have loads of coffee shops. So we are more with the used grounds. So and with the lab as well. Maybe it won't be maybe specifically a cup, but more like a workshop, maybe to have people come and learn and understand and have the shared knowledge of what it could be. So I think, yeah, we look at the
Actually, I
different.
love the idea of drinking coffee from a cup that's made out of coffee. It just,
It does exist. It already.
Yes.
There's a German company. Well, don't know because it's not the open source, of course, but there's a German company called Coffee Form, which made really high-end coffee cups and coffee takeaway cups out of used coffee grounds. It's one of the post-it notes. If it's with the links.
But it's made out of coffee waste materials.
Yeah, a German company. Yeah. So
the problem of those, there are many companies doing it, but then in the end, is you just put a very small fraction of coffee waste, and then you use a resin, and then of course it has coffee, but it already have also synthetic resins. So I don't know if there is any case in which they are made with biomaterials. That's the other big issue.
Yeah, no, I think this, in my mind, this is going to be a materials project if you want to take that on. Go ahead. One comment, and then I'm going to switch so that
Just like not really based on any knowledge, but I just feel like it would be interesting to see if banana leaves could be a good holder.
Yeah.
I don't know what would happen at high temperature. But.
Yeah.
I was also thinking of coconut shell.
So where you don't destroy the structure of the material to even begin with. But I think, in general, the support material and what is that replacement of what makes things waterproof. I think that's the key. The mechanics I'm not worried about. It's the water, that's really the one challenge which we've faced in many other projects itself as well.
So actually, we can just point a reference on a project that is very known, the Precious Plastic. They started developing this heat press with metal mold, which you can press just coffee or any other things, and they end up doing from dish and cups. So actually, it's been tested already. It's holding for a while. Then we just require these kind of low-tech heat press machines to start trying, and then maybe improve a little bit on the material side. But then
I would start with that, but really kind of test the thread, whether for a given temperature and given time, whether the material holds. I think that would be very valuable as a starting point. Okay, so I'm gonna switch.
Yeah.
And so let me see who's going next. Let's have Kimberly and team. Do you guys have a team name, by the way?
Not ready. No.
Okay, all right. Yeah, I think when you're all making the Discord channels, you guys should try making the time to make the team names. Oh,
Does it have to be related to the project?
no,
No?
no, I just the name when I'm thinking about you guys. That's all.
So Bali Team 2 works in a way.
That's correct. Yeah.
No, just a
That's-
guess.
Do you want to connect through your computer itself or? But I can also just share through here. Oh, and then, oh, I see what's going on here. Deep sea. No, here. Docs. Perfect. Okay. FRDPARRC. Okay, take it away.
And we're also partnering with Smerty and Rishika online. I'm not sure.
Fantastic. That makes me happy as the first team that's crossing the Atlantic. Okay, I'll let you guys navigate this. It's a
Cool. Thank you. So this is like an idea about something in words better. Basically the problem that we were trying to tackle is what we went over last time in class, where we're looking at trying to identify species that are in the deep ocean, because it's like very unknown at the moment, and in order to be able to protect those species that are there and have better conservation movements, we kind of know what's going on there, maybe even track migration patterns, and see like how species are doing there. And so for the functional requirements, we were thinking of having some sort of device that's able to go into the deep water, somehow collect samples, and then get some sort of genetic or molecular level testing of that, or like get maybe like DNA, so that we can identify the species that are there. And so one of the requirements is that we need to be able to deploy this device into the deep ocean and then retrieve it. And then, like I said before, we want molecular level monitoring. And if we are using something like nucleic acids like DNA, DNA isn't stable over long term, especially when it's in contact with salts or with water. So if we are trying to retrieve this and we bring it out of the water, out of some sort of stable cold environment, we want to either stabilize it. For example, some ways we can do that are by adhering to a sort of fibrous membrane, or we want to freeze it immediately. And so that's another requirement that we need to take care of. We want this device to be able to be deployed globally, so that we're able to collect samples from across the world. And so that, of course, brings in the issue of like making sure that this device is accessible to everyone, that it's like lightweight, that it's frugal, that it's not going to be environmentally damaging, because we want it to be like legal everywhere. And also it should be durable, so that it can go into the deep ocean. And then so moving off of that, a couple of the design parameters we're thinking. One is that the deep ocean, of course, is under a lot of pressure. And so if you have something that is in an enclosed space, you can't just like bring a water bottle down, collect some water, and then bring it back up to the surface because it could literally explode because of the pressure changes. And so we need to have a way to mitigate that. And like I said before, we also need to be able to make sure we're not damaging the DNA and compromising our samples because the DNA is not stable anymore. So that must be considering, do we want to immediately get the DNA samples to be frozen, meaning that we need to retrieve it immediately? Or do we want to somehow figure out a way to stabilize it long term so that we can do something where it's like it floats a while and eventually is retrieved more long term?
Yeah. And I think in terms of functional requirements, the categories are fantastic. Just put some numbers on it. Say that it will be stable for 1 year. Because that's very different from saying it will be stable for 100 years.
Yeah,
And it force your technologies. And though similarly with the deep sea, the deepest ocean can be 11 kilometers. The average is like 4 kilometers. So it's valuable to just say, okay, we want to retrieve samples from a 4-kilometer range because there are other challenges when it's deeper than that too.
Yeah, I think DNA can be stable at least like a month or something if it's at room temperature, if there's like no moisture and no salts. So I don't know the exact numbers of water, but obviously both of those
But
categories
it's
are there in the
useful to
ocean.
just put the
Yeah.
number out.
Yeah.
But I would put that number out based on your retrieval technology. If the retrieval is passive, you don't get to decide, and it might be a broader window. But it's still useful, and then it pushes you on saying, oh, we need better ways of molecular storage. And I think it's feasible. I think there's a lot of work happening right now in very seriously DNA as our hard drive. So tons of people are super excited about storing DNA in ways that's how we will be storing data. And for that reason, you don't want your hard drive. So there's a lot of work in stabilizing DNA and other sets of scenarios. Any other functional requirements, categories that are there other categories if you go further down?
Yeah, a couple more, just like one is geotagging, just so that we
Yeah.
know exactly where our samples are coming from. We want to know the depth and also the location. And depth is really important too, so that we can track whether there's species moving up and down different zones, and that would be helpful for like migration patterns. And last, we want to also consider who our users going to be. Do we want this to be expandable to citizen science so that a lot of people are able to deploy it? Do we want it to be specifically for scientists and organizations? So that's something we're still considering and haven't answered yet.
Yeah, and I think the other functional requirement number I would write is just write the cost would come from total number of samples. So look at the surface area of the deep sea, and for it to be even a very small percentage of that biodiversity, how many of these little balls that I'm imagining do we need to drop in the ocean for it to matter? Like if it's just done as a 1 or 2, which is people do that all the time right now, they take submersibles, but the whole goal is that the total sampled area of the planet is very small. And so if we want 0.0001% of the biodiversity, how many total sample points should be made? And that'll tell something about the cost.
Yeah.
Because then you'll feel, oh, wait a second, we need 100,000 of these dropped, and the ocean is a big place. That means operationally, every unit should cost less than $100 because that's 100,000 multiplied by 100%. If you know that your retrieval rates will be only 1%, suddenly that's another cost hit because then it's like, oh, I'm not getting any of them back. Yeah, so I mean, putting explicit numbers would be very helpful at this point. Other comments, threads you guys want to make?
Yeah, totally. So something to kind of give a scale for the numbers. Yeah, we haven't defined those yet, but as like a comparison of what's kind of out there right now, we found this example. Oh, maybe it's not gonna open it. Okay, the paper might be blocked. You have to like download it. But anyways, it's an example of a underwater rover that they launched at Monterey Bay. So just like a few hours from here. And theirs is like remotely operated, completely like mechanical. There's like batteries involved. It has a life of around like 18 hours and can go down to around 4,000 meters. And they get like, they'll collect all the samples and measure them in situ, like underwater. And there's a bummer it doesn't open, but there's a cool diagram of their system with all the buffers that they put in. They're using quantitative PCR. And it gives us some numbers to compare to. Definitely extremely expensive.
But I'm surprised, you're saying they actually did PCR underwater down below rather than bring the samples?
Yeah, they said they were doing it in situ, which was
Very
interesting.
puzzling to think about why they would do. I think it's much more of a technology demonstration.
Yeah, perhaps.
Why would that, yeah, why not bring the samples back and then do a, yeah.
Yeah,
mean,
I'll have to pull up the paper
Yeah,
so
I
we
know
can
Peter
go
very
through
well, so,
their diagram.
Yeah.
Yeah. So that's something to kind of give us a comparison, and I think it's definitely helpful at this point to set some goals number
I think
wise.
the reason I'm excited is we are thinking about more of an orthogonal approach to this. Often enough, deep sea is often threaded in terms of the macroscopic biodiversity, but
Yeah.
what people are realizing slowly is that the microbial, because the rover goes out because you need a camera, you want to be able to see what's out there. And that was traditionally how you would think about biodiversity. But if we flip that around and say biodiversity is really the highest biodiversity is in the small scale, then what we really care about is we don't need cameras, we don't need any instrumentation. The goal for this should be is that we build this with completely passive mechanisms. That would be the most exciting thing. And I think it's just, we're thinking very orthogonally to how people think of expeditions and explorations, because most of these rovers, to keep any electronics and much of this survive, they become extremely expensive. And again, I think people in deep sea exploration are starting to realize that sending humans down is not safe. So most rovers currently are just remote operated. They don't have humans that go in because you can see everything from cameras and stuff. And we're taking the next step, which is you don't need to see anything. It's all microbial to begin with. What's most, I mean, abundant. Yeah.
So something that might be worth looking into is there's a like a Frugal rover kit that like I know like my middle school use this that you can build called Sea Perch. So I don't know, it's not like for deep sea, but that you might be able to get some ideas on how to like, I don't know, design something like that. And I think that one is attached by for fully autonomous.
But the goal here is no electronics, no rovers, nothing. We're just dropping balls from a given point. They sink within 2 hours. And then after 2 hours, they trigger a buoyancy mechanism that make it drive up. And actually, you can also think about this from a calculation. So I was doing this 2 days ago. For a penny, it takes around less than a day for it to reach the bottom. So it's kind of interesting that the journey to the bottom, if you're going straight down, it's not that long either.
Yeah.
And so it's possible that the sets of things that are deploying might also be the things that are retrieving. Because if you can retrieve it sooner, then you don't allow it to just float away. And I think retrieval is going to be the hardest problem. Like even giant buoys are very difficult to see in the open ocean. So retrieval is where the problem lies in this, how to think about retrieval.
Yeah.
Okay, let's switch so that I'm just trying to rush you guys a little bit for the next 20 minutes. Do you guys have a team name? Okay, not yet. Yes. I see next is Steph. Okay, go for it.
So like our project is going to be about how to make the waste process of clothing more sustainable. So to kind of give you an overview of what that looks like right now, nowadays, as you might know, with the rise of fast fashion, a lot of clothes is being produced, they're bad quality, and a lot of water is being wasted on it because it takes a lot of water to process cotton, to produce dyes or whatnot. So that's one part of it. The second part of it is at the end of the life cycle of clothing, a lot of it ends up in the landfill, whether that be someone donating their clothes to thrift and then eventually people not buying it, so you have to dump it into the landfill. That's usually the case, or like people just straight up just dispose their clothes. So we're trying to find a way to reduce the waste and the amount of clothing that ends up in landfills. So we came up with kind of like this linear like process of going from functional requirements to countermeasures. So the first one is looking at how to reduce the amount of clothes that ends up in landfills just overall. So a design parameter we came up with was designing fabrics that can be more easily recyclable. And so we would have to look at the material's lifetime durability, post-recycling, and what does recycling cotton versus polyester versus whatever other materials exist, and what that looks like. What's the typical input and output? Because with recycling some materials, you may not get the maximal output that you would want. And then looking at recycling costs, because that's a big issue as well. So some resources we would look at is production knowledge, textiles, blends, current recycling processes. And something that we kind of stumbled upon was that because there's so many different blends of clothing, that makes the recycling process more difficult because not everything is so cookie cutter. There's so many different blends and people would have to find a way to sort them, and that could be very costly in terms of time and money. So yes, that's what's covered here. And also it's difficult to scale just because of there's so many different ways that clothes have been made. So it's just overall a very large problem to tackle.
So just on that, I'm just reflecting my own ignorance. Now, when I think about, take a t-shirt, can a t-shirt be turned back into a thread for cotton and back again? Because I can't even imagine in terms of the, it's a fabric kind of a format. What's the current, is there any gold standards out there in kind of references section, for example, in that, where I could take a fabric, even if it was pure, and turn it back into actual fabric again?
Yeah, I don't think there is a gold standard. So there isn't like any large infrastructure set up for it. I think one example that kind of comes to mind is like the Nike Space Hippie line. So what they did was take a bunch of their scraps and plastics or whatnot and use that leftover waste that happens during their production of shoes to create a clothing line, which includes like clothes, shoes. That might be like the best, but it's
shoes made out of clothes.
Yeah, like old
Got it.
textiles as well as like
Got it.
plastic.
I see. So it's not breaking it down into its complete raw material, but just use still the fabric itself.
Yeah, I think the fabric is like very like small and like cut up at that point.
Yeah.
But
I
I
think
think
it's mostly synthetic still, right? Are they also recycling mostly synthetics for the Space Hippie line?
to be honest, I forgot. But
Okay.
yeah, so like I think in this example, the materials that they got to make these products were in-house, but there's no large global or like centralized resource, and that makes acquiring recycled materials for the production of clothing difficult and more expensive. And it's just at that point, it's just cheaper to make something from like new materials that may not be the best quality. And then another risk would be if you were to make clothing from recycled materials, the quality and durability of the clothing is in question as well. But yeah, that's one thread. Do you want to?
Yeah. Should I go? Do you want me to do you want me to talk about upcycling?
Yeah, sure.
Yeah, so I mean, we touched on some of this, but like something important, something that an idea we discussed, and I think that was like pretty central to us, I think in our first ideation session, was upcycling, or like at least being able to use garments that you're discarding that you no longer have a use for maybe a different purpose. Like if you cut up a shirt, there's a lot of ways that you could use the fabric available. You could do bandages, you can make rope, you could I mean, actually, I can't list everything, right? But so we were. Wait, hold on. Oh, did something get shuffled? Yeah. So so we actually did. We were talking about being able to use clothing, like design clothing where you could use it in other functional settings. But yeah, there also is the thought of recycled material where, okay, we already covered that. But yeah, and then another sort of idea we were talking about was how to reduce like the water waste, at least minimize the impact done to the environment by clothing production. I think for every, I want to say kilo of cotton produced, you're wasting something. You're not wasting. You're using something like 7,000 to like 20. I think it's 27,000 liters of water, which is kind of a lot. A lot of that gets used in growing the cotton itself, and a good chunk of that comes from processing the cotton and doing dyes, and all of that water ends up sort of getting polluted. So when water comes out after cotton gets processed, it's not really usable for much, and so the textile industry becomes responsible for like a lot of the water waste that goes on just worldwide. So something we did start looking into was like alternative fabric options. I think two big ones we found were like hemp and organic cotton. Not entirely sure about organic cotton because it sounds the same as just cotton. I didn't look too far into that, but like hemp seems like a pretty good option, at least environmentally. Not sure how it feels as a fabric. I don't imagine it's fantastic. But we think that might be interesting to explore. But a couple risks that do come with like using alternative fabric sources is that like a lot of those industries, a lot of those like methods for processing and or farming, like these alternative fabric options might be less developed and thus more expensive, which I think makes it really hard to scale these solutions up really quickly, even if they are just like cheaper in like, I don't know, water costs, production costs, or like, yeah.
So what are the numbers? Are there numbers that you could find in terms of, because I think these are multiple different projects, and one idea would be just choose one.
Yeah.
Just really focus. While many of these problems do have interlinks. I think all of them are super exciting, but for the kind of the granularity of how you would approach it, I would just choose one of the actually at least the three clear that I can see, because everyone would require a very different approach. So it's not even comparing. It's just fundamentally even a different problem.
Yeah, I think at this point we're just probing at the overall general space. Because we're not sure which one would lead to the most practical end project for us.
I think one way of thinking about that is just choose what you're passionate about. And what's important is to go as deep as you can as quickly as possible. Even if there are lots of roadblocks that you see, it's about identifying that process. That's the key goal of the class per se, is that by the end, you've really refined it to a point that if we had a ton of money and a big team, you could really attack it, and you really distill that there is an idea that has emerged out of it, right? You're in a problem phase, and all we want to do is make sure we get into an idea phase, which is like, oh, I think we have an inkling of a solution, and this is why we believe we can back it up. And I mean, all of them would be fantastic, but I think one, because there's no bandwidth to be able to do them all. And I think the other thing I would do is put some numbers in to just get a sense, because clothes are made in such broad contexts. One thing is, so different countries also will start, different scale of production will start to change and actually this is also almost a cultural issue too, because clothes are reused. So do some numbers to get a sense, because between those three, it would change dramatically if you choose. I think you should choose US numbers as an example. This would be something that would be very valuable to anchor in the US context.
Yeah.
Okay, any comments, threads?
Threads.
So there's one comment on Jen that you should check.
I'm getting better at that.
So Shannon, if you put in chat.
Oh, yeah, let me write that down somewhere. I'll write that down later.
Fix it fashion and make your shoes
Fix it fashion. Yeah, that's good. Okay.
Thank you, Shannon.
Unless there was another.
You're welcome. I would just want to add because I met the Makers Unite in Amsterdam, and they had this big, because most of the work line are people who immigrated there, and they did this whole big project where they took a vest, like a safety vest that people use to travel. And when you use a safety vest, no, life jacket, sorry, not a safety vest, a life jacket. When it's used once, you can't use it again. So you have loads of life jackets that are unusable. And they made some clothing, they made some bags, they made some ribbons, and Fix It Fashion is made by the people who from the plastic ones, the big one, and it's what it's just this open source documentation of how can you reuse your t-shirt and make it a dress, or how to fix a hole, or learn about materials, learn about different stitches, and have a look. It's quite inspiring.
Yeah, I think it's in the chat, right? If you have the links, just add it. I'm seeing this says the last team. I'm not seeing. Oh, Baba just posted. So Paula, are you online?
Yeah, Manu, can you hear me?
Perfect, take it away.
Yeah, okay. Well, we were discussing with Elaine.
Would you like to share the screen, or do you want me to do it?
No, it's okay if you can share it, please. Okay.
Yeah.
Well, we were discussing with Elaine and Pierre, but unfortunately he's not able to connect today. Well, I decided to join to Elaine's group, since she was talking about emerging zoonotic diseases. So we started to take some previous ideas from the boards of the 2020 and 2022 related. And we start to make some brainstorming about how can we approach this topic, since we consider that in Asia and Latin America, we share a lot of weather or climate conditions, similar conditions, as well as social economical issues too, that condition that some health topics. So we were talking about what kind of materials or requirements we need to make this worthy for the specific location, either in Asia or Latin America. And we still need to discuss a lot to define what is the area that we're going to choose. But we were like checking some information about zoonotic spillovers, since, well, Elaine is not biologist, but I am. So we think it's like an interesting merge from my side to contribute with all this biological information, and for hers to learn how to design, because I know it's not that easy. And yeah, we were like putting some ideas and some references that we consider that are important for this. And so yeah, we need to organize better our ideas to have like a more defined proposal.
I think one comment that I would make is I'm assuming the direction that you guys are going is diagnostics and
yes.
If you care about, I think it would be very valuable to focus on the spillover side of the story, not just diagnostics on the human front, but how do we really do surveillance on the spillover. If you end up choosing vector-borne, and specifically, I would narrow it down. If you want to choose that by itself is a very large space. Choose a specific, I think regions you already mentioned a little bit, but then also you can very narrowly focus on the disease itself.
Yes, yeah.
One disease and see whether the surveillance of that can be improved by an order of magnitude. And so I think what would be in the functional requirements, it would not just be the cost of the hardware, but just how much do you want to improve? What is the current gold standard in that problem? So let's just choose dengue. I'm just making it as a reference. If we choose dengue, we know its occurrence across the world. we have a certain sense of numbers, and then you might want to say that, okay, what would it take to improve our capacity tenfold in something like that? And that'll give you a sense of how broadly accessible a given solution needs to be for it to matter.
Okay. Yeah, well, I didn't mention more specific details. Yeah, we were talking about to focus on a vector-borne disease. We need to decide which one, of course.
Yeah.
And since we were like considering, for example, viral diseases like dengue or chikungunya, we considered that maybe with a Frugal tool, we will not be able maybe to see the viruses itself or to implement a molecular feature, but we can focus on the vector itself, maybe to monitor or to make some screening on the water storage, since there you can find the larvae. And yeah, and also I was talking with her about the One Health approach that the CDC has like published a long time ago. As you mentioned, not to focus only in humans itself, maybe not in like the diagnostics for our part, but to focus also on conservation, on environmental health and animals' health, because all of them are related. So, well, we have to discuss more, and yeah, I hope for Thursday we have like more clear, a more clear approach. Yeah.
Okay, I'm gonna switch to I'm seeing Baba as the last one. Okay, Baba, take it away. Oh, he was right there a minute ago. Did he just disappear? I know he was there. Everybody saw him, right? Yes, yes. Okay, I think he just went to the restroom. I can, he chose the thin red line problem. That's good. You can already go through the problem. I love how specific it is in the context of the functional requirement. This is in the context of RDTs. We had talked about the HRP23 gene deletions, the test cost itself. And I think the thread that's different here is transitioning to getting as low as 50 parasites per microliter. And I think, yeah, the threads that we were discussing is how to transition from not reading by eye, that the test might still be working, but you miss it because you can't see repeatedly the eye. So the notion is just like in your COVID test, are there other techniques to read it out that's much more either electronic amplification rather than purely optical amplification? So everybody knows, right, when is this obvious? I think I talked about that in the class, right? The thin red line problem. If you do a COVID test, there's that faint line, you may or may not see it, but could you amplify that electronically or by some other readout? So I think optics is one thing that we've been thinking about. Electronic approaches is another. There is acoustics. And because it is essentially a band of gold nanoparticles, before they are visible, they might have a signature that's visible that could be read. And I think, yeah, that's the problem that Baba is describing. Since he's not here, okay, we'll pick this up on Thursday, essentially. So I'm gonna stop sharing. I don't know if everybody here already went through, right? And I guess Adil and what was your name again? Ben? Bem, yes, Bem. That's gonna be an easy name to remember. We'll pick that up on Thursday. And then anybody else online who didn't get a chance to go today, try putting something together for Thursday so that we at least have gone through every FRDPARRC, because at this point, you should all feel very specific about the kinds of problems that you want to work on. And I think one thing that I would like to do this week is to do one-on-one meetings so that it's very clear in terms of what you're trying to accomplish in the next couple of weeks. And let's do that for every team. For certain sets of threads, there is already tools and technologies that we can make sure that can be in your hands to begin with. And for certain other teams that would involve building completely new sets of threads. But it's valuable. I think the way you should think about, Baba, I just went through your FRDPARRC for the class. Yeah, sorry, because, and we'll pick that up on Thursday again. Yeah, but the comment that I was gonna make was, this is, as you're starting to choose a project, the goal that I want you all to demonstrate by the end of the class is that you have a certain sense of a mastery in understanding that problem, and that also that you've been able to decipher through which are the paths that are the right ones to take, and then actually take the first sets of steps that you would want to take in that path. Because, you know, lots of folks, we end up identifying problems. That's good, that's one thing. But then you also have to identify a crack in this fabric to say, oh, and now I see this would be a kind of a solution, and then convince yourself amongst many solutions that are possible. So what we'll be getting to the point is where you have certain sets of things on the analysis column where you feel very confident that, oh, I think this will work. This sort of an idea. So just picking up on what Baba and I had been discussing, the thin red line problem, we would literally take a whole bunch of faint tests and we would measure them electronically. We would measure them under a microscope. We would collect the kind of data that tells you that the path that you're taking essentially is starting to go towards the right path. And that's very important in the early phase because so many possibilities, you could commit to one thing and only much later realize that, oh, there was a fundamental flaw in that approach. So the goal really is to make sure that amongst many of the sets of ideas, there are certain sets of things that we are deciding that we will push ahead with. And so I think this will do when we sit down and narrow down based on the resources that are immediately accessible. It's perfectly okay in the context of a project to change certain functional requirements because of the resources that might be at our hand. Like you might have a particular class of phones, so then you end up just focusing on those. Or we might have very particular compound libraries, and so we might just focus on that for right now as a test case. So I think that's really the transition point where things start to become real. And so I think on Discord, let's fix those times. I'm thinking tomorrow is Wednesday. So Wednesday is a good day. And then Monday is another good day. So I'm going to clear up those 2 days.
If you want to give us times, then we can send
Yeah, just a doodle poll. And then I think this is also true that you should independently sit with the TAs itself. Everybody here has slightly different expertise, and it's just useful to have one-on-one discussion times with your team. And also this should just give you, at this point with your team, you should have a regular set time. So, you know, not just meeting, right, if you have something to present, but just regularly actually meet. And then if you haven't recruited people in your project, try recruiting people, or the other way around, just to make sure that everybody gets a chance to participate itself. But I think, yeah, tomorrow and Monday would be 2 long slots that I'm going to clear up. Okay, I think we'll say bye and we'll catch you Thursday.
Thanks, Manu.